looking at cosine rule now. So cosine rule, again, we're going to do cosine rule, we'll do proof, we're going to do an exam question. So the exam question is going to use part of cosine rule, part of sine rule, and part of the area that we did in the previous section as well. So cosine rule, again, works for all triangles like the sine rule. Similarly laid out. Okay, looks kind of the same in your log tables. All three rules, so your sine rule, cosine rule, and area, they all use the same diagram, so the triangles are laid out the same way. And the key thing with the sine rule is that, or the cosine rule, sorry, is that we only need one angle. Okay, and then that angle is the one opposite the first side, the A. So we have side A and angle A, and then we have side B and side C. So what we use the cosine rule for is usually to find the third side if we have two sides an angle. Where it can come up a lot is with maybe area, because if we have area, maybe given this information, we might be given the area and asked to find that angle and then use that to find the last side. Or we might need it to find the angle when we have all three sides. So kind of different to your sine rule, we need to either have all three sides or two sides and the angle between them. Those are kind of our two needs, I suppose, there. So looking at how it works in practice, I suppose, if we're given a triangle like this one, where we're given the side of AB, we're given AC, and we're given the angle, we need to find CB. So let's just kind of label everything as best we can. So side AB, I'll draw a little sketch here, or we'll use the sketch that's there actually. So side AB is 8, so that's here. Side AC is 10, so AC is 10, that's here. BAC is 50, which is this one here. And what we're looking for is CB, which is side A here. So our rule, A squared is B squared plus C squared minus 2BC cos A. So let's fill in the bits that we have. We're looking for A. For B and C, we can technically fill these in either order, but we'll stick with the way that we have laid them out. Cos A is 50. And once we've gotten this far, I suppose we can really just put a lot of this into our calculator and maybe just working it out that little bit extra just so we have kind of some workings shown. But we could put this all in our calculator at this point. So minus 160 cos A cos 50 was, let's just work all that out together. So 160 cos 50 gives me 102.846. So A squared is 164 minus 102, which gives me 61. So I get an answer for A of 7.82 centimeters. Okay, and we could round that up to maybe around about 8 centimeters. Okay, so you can see there, same as with your sine rule, we sub everything into the correct part, and once we've that done, then it's just a matter of kind of computing the answers. So in the next part, we're given the three sides, so we're looking for the angle. So the angle we're looking for is opposite side here, side 9, which what that means then is that 9 is going to be in place of the A in our formula. Okay, everything else we fill in as normal. So remembering that we need to have the angle that we're using has to be the angle between the two sides, B and C. And then the last side, A, is the one that's opposite the angle that we have. So again, just working out maybe some of this information to show some working, to show an examiner that we know where we're at. 24, 2, 7, 6, 8, minus 95.2 cos P. Okay, and we can sort out a lot of this here. So we get minus 14.24 is equal to minus 95.2 cos P. So cos, or cosine of P, is going to be 89 over 595. And what we don't need to worry about here was the ambiguous case that we had with the sine rule. So with our cosine rule, we can't have that ambiguous case because we can't have an option where we could have a second angle that's less than 180. We already know with cosine that cosine is only positive in the first section, in the first quadrant, and the last quadrant, the fourth quadrant. And obviously all those angles are bigger than 180. So if we were to find the other option, it's going to be too big for the triangle. So we only have one option, and it's 81.4 degrees. So looking at, let's do a sample exam question, kind of using what we've done in this part and the last parts. Looking at the diagram below, which is a triangular patch of ground SGH, and SH is 58, GH is 30, and GHS is 68. The circle is a helicopter pad, it is the in circle and has centre P. Find SG. So that's where we're going to start. Find SG and give your answer in meters, correct to one decimal place. So we're looking for this side here. So looking at the information that we have a side, and we have an angle. The angle between those two sides. So what that suggests to me is cosine rule. So that's what we're going to do. Okay, so we'll maybe do it to the side here. So starting with part A, I'm going to use my cosine rule. So A squared, and I can look at my log tables. I don't need to know the rule off. Okay, filling in what I have, I'm looking for A, so we can call that SG, because that's what I'm looking for. B and C, go with either way, so long as we're consistent. And then cos of A, we're saying is 68 degrees, cos 68. SG squared, okay, 30 squared is 900, plus 58 squared. And again, as we kind of said in the last one, you could do this whole part on your calculator without having to work out these individual steps. It just sometimes is a good idea to show as much work as you can to give yourself an opportunity to kind of pick up those marks. So we get 7, so SG is the square root of that, so 54.4 centimeters. So SG is 54.4 centimeters. Perfect. Okay, we need to look at part B now. So part B asks us to find angle HSG, which is this angle up here, giving your answer in degrees. So looking at that, we can look at all the information that we have. So we now have this side here as 54.4. So what we could use is, again, we could use the cosine rule. We have the three sides. So if I was to stick with, we'll use a color for this one. Let me change this here. Kind of stay consistent with the colors. So if we were looking for that, we have these three sides. So I can use my cosine rule to look for the angle. What we could also do is we could use this side and the angle opposite it, and this side to find the last angle using our sine rule. So because we haven't really looked at one using the sine rule, maybe that's what we'll do. So we're looking for sine of angle HSG. Okay, so we're looking for sine of angle HSG, and we know that the side opposite it is 30. And using sine of 68 and the side opposite it, 54.4. So sine of HSG is 30 sine 68 over 54.4. Let's just get that maybe a bit more of a normal looking amount. So 0.5113. Okay. Converting this now, we get that HSG is sine inverse of that, 30 degrees. 30.75 degrees. Okay. If we were to look at the other option, if we were to kind of just, we'll not actually maybe write it out, but if we were to look at the other option, it'd be 180 minus that. Okay, remembering that ambiguous case we had, which gives me 149 degrees. And 149 degrees is too big. Okay, because we already know one of the angles is 68. If we added those together, we get an answer of 200 and something. Okay, so too big, so we can't have the other option. We also know just by looking at the question, so the diagram shows a triangle. Okay, we can see that that angle is acute, so it's fair enough to just assume that we only take that case. So we have our angle as 30.75 degrees. The last part asks us to find the area of the triangle. So we can use any of the points we have. In an exam question, I would nearly be inclined to use the information that they gave you. Okay, that's just personal preference, but just in case you've made a mistake in any of the parts, even though that will obviously be considered in terms of marking it, I would just tend to use the information that you're given. So half AB sine C is our formula, and I'm going to use the two sides that I was told about in the diagram originally, and the angle that I was told also. And multiplying those, I can work out my answer as 806.65 meters squared. Okay, 806.65 meters squared is my area of that triangle. So we can see how in these exam questions we often have to make kind of choices about which of the rules we use. So for part B there, I chose sine rule, but we also said that we could have done cosine rule just as easily. With the last part using the area, we could have used any of the sides because we have them all. We also had the angle there at S, so we could have used that one and used the other two sides. But I tend to go with maybe the ones that they've worked out for you already. So just as the last part, we'll just quickly look at the proof. Obviously, again, this is in your notes, this is in your book, so it's one just to know how to replicate and reproduce, but just to make sure maybe that we know each of the steps that we're looking at. So we want to prove the rule, which is a squared is equal to b squared plus c squared minus 2bc cos a. Okay, so what we'd use for this one is we use our unit circle. So sketching out my unit circle, we're going to put 2 points on my unit circle here. This point is going to be the point b cos a, b sine a. And what I've done is I have, draw that a bit better, so we can make a note here in terms of my construction, and we are increasing the unit circle by a factor of b. So instead of the radius being 1, the radius is now b. Okay, so we've that 1 point put in. Another point I want to have here is the point C0. Okay, so just the point C0. I'm going to draw a line to connect those 2 points. Hopefully it doesn't send the thing haywire. Lovely. Okay. So, connecting up all this information, we have those points. We can draw in some angles. So we'll call this the angle A because it's going round to B there. I'll actually just do it in red so that we keep everything kind of lined up together. We'll maybe call this one C because it's opposite kind of where my point C is, and we can call this B. Okay, so we need to use some of the information that we have, and the best thing we can use here is to look at the distance between these 2 points. So the point here and the point C0. So that's what we're going to start with. We're going to look at the distance between those points. To do that, we're going to use our coordinate geometry. Okay, and we should remember that the distance between 2 points is x2 minus x1 squared plus y2 minus y1 squared. Again, that's in your log tables anyway, but it's one you should remember from junior cert. So that distance, given that this is angle A, we can call that side A. So my distance between them is going to be side A, and it's equal to the square root of x2 minus x1. So let's take as our x, we can take the b. x1 then is c squared plus b sine A minus 0 squared. Okay, continuing on, I can square both sides to get b cos A minus c squared plus b sine A squared. Okay, and I will square out those brackets, so I get b squared cos squared A minus 2bc cos A plus c squared plus b squared sine squared A. Okay, continuing on, A squared is equal to, what I'm going to do now is I'm going to take out a factor of b squared, and that will give me my cos squared A plus sine squared A. I'm going to have my c squared, and then my minus 2bc cos A. We can probably see how I'm trying to rearrange this. So taking the 2 parts, the 2 terms that had b squared in them, the c squared, and then the 2bc cos a at the end there. That's kind of where I'm going from this step to this step. Something we need to maybe be aware of is that cos squared a plus sine squared a is actually equal to 1. Okay, and that's really important. It's an important identity. It's in, again, it's one of these things we use in a lot of these rules. So cos squared a plus sine squared a is equal to 1. And because of that, we get that a squared is b squared plus c squared minus 2bc cos a, which is what we set out to prove. And thus we have our theorem. Okay, so key thing there, I suppose, is your setup at the start. So setting it up in such a way that you're able to prove it, I suppose, and then following through with that using your coordinate geometry, using your distance formula, and using that identity here, that cos squared a plus sine squared a is equal to 1. So those are all kind of the key parts of your cosine rule proof. So with cosine rule, key things we've said, they're really just generally similar to sine rule, making sure we've labelled our parts correctly, making sure we've labelled angles correctly, that we're definitely using the correct one in the correct place, and knowing when we can use it. So we use it if we have all three sides, or if we have two sides and the angle between them. Generally, those are the two times that we can use that one. And we kind of saw in that exam question that a lot of the time we can move between sine rule and cosine rule fairly easily. A lot of the times it's kind of up to yourself which you prefer to use in the question.